Okay, so now we'll be moving to our next topic within the inheritance, right? We have already seen some basic concepts. So today we'll be starting our discussion, as I told you, with the constructors, right? Because we did not explicitly discuss about constructors, that how constructors are inherited and in what order they are called, right? So today's discussion will be focused on that. Okay. So first, maybe I can give you a hypothetical example just for the explanation of the concept, and then later maybe we can do a example which you can correlate with the real world. Okay, so let's start. So what I'll do is I'll just make two classes, a parent class and a child class. Okay, and I will only be focusing on the constructor, nothing else. Okay, so later we can add other functionality to this these classes. Okay, so we have a parent class which I'm calling base, parent, whatever you want to call it. And within this class, I will make two constructors. Okay, so first I will make a no argument constructor. And what I'll do, I'll simply display something. Okay, maybe I write this is default constructor. That's it. Similarly, within the same class, maybe I can make a parameterized constructor. We pass it an integer. Okay, and we can simply print the value of this integer. Okay, whatever is passed, we just print it, and that's it. That's all. Okay. Now let me make another class, maybe a child class. So we make another class. We call it child. Okay, and in order to do inheritance, just a quick reminder: what is the syntax? You put a colon, and this is a single colon, right? Not double colon, which you have in scope resolution operator. And then you write the name of the parent class. So the parent class is base. So I'm just writing base here. Okay. Now everything which this parent has, it has been inherited by the child class. For this example, we don't have any data. We only have two constructors, right? So within the child class as well, I'm not taking any data. I'm just making two constructors. So I will make first a constructor which is not taking any arguments. Maybe we can say child and default. I'll also make this program so that you can see the output, right? But presently we are only discussing. So I pass it some integer x, okay? And within this, I simply display the value that was passed, okay? And that's it. We conclude this class here. Okay, now we'll be making objects of parent class and child class, and then we'll see what is going on, okay? And again, this discussion is only from the perspective of constructor, okay? Nothing else. So in the main, maybe we can write the main here. Okay, what do? We already know that if I make an object of the parent class base b, what happens? Object is created and this constructor is called. Okay, so you see default constructor on the screen. On the other hand, if I make an object like this, base b, and pass it some argument integer, what happens? Then the parameterized constructor is called. We see the value 2 printed on the screen. Okay, so this is something we already know from our previous knowledge. Now, instead of making the object of the parent class, I will be making object of the child class. Okay, so now let's see what happens. So I write child c. It means I'm not passing any value. So I expect that it will call the default constructor. Okay. Now, in case of inheritance, what happens is that whenever you create an object of child class, okay, so in this case, we are creating an object of child class using this constructor. It will come here, but before executing the body of this constructor, it will first call the default constructor of the parent class, right? The default is important, that whenever you make an object of child class, before calling the constructor of the child class, your program will first call the default constructor of the base class. So in this case, what will happen? First, you come here, but before executing the body, it will go here. It will call the default constructor of the parent class. we see this printed on the screen. This function or this constructor concludes here, and then it will come back and it will execute the body of this. So what you see on the screen, first you see whatever we have written in the parent class, and then you see whatever we have written in the child class. Okay, so this is what is happening, that before executing the body of the child class constructor, it is executing the body of the default constructor of the base class or the parent class. Okay, now there are different combinations possible, as there might be certain questions in your mind, so I'll explore all possible combinations, so they will actually clarify whatever queries you might have in your mind. So now let's say instead of making the object of child class like this, I make an object of child class using a parameterized constructor. Okay, so what I'm now trying to call this constructor. So what happens, this 5, it will actually go into this X, right? Now, a little while back, I just told you, before it can execute this body, what it will do? It will first call the default. Okay, default is important. It will first call the default constructor of the base class, means this will be executed, and then it will print this 5 on the screen. So what happens? What would be the output? Output would be default constructor. This is printed from the base class, and then you see a 5 on the screen. Okay, so in other words, whatever constructor of child class you call, because in child class you can have many constructor, no argument, one argument, two argument, three argument. Okay, it depends how many data members are there. No matter what constructor of child class you call, before executing its body, it will always first execute the default constructor of the parent class, and then it will execute the constructor of the child class, whichever you have called, right? So this is one thing. Now another thing which you must be thinking, or it is natural that it can come to your mind, that what if I want to call the parameterized constructor of the base class? Okay, it means that, you see, whenever I am calling the parameterized constructor of child class, we expect that for the parent class this constructor should be called. Okay, so if you want it, it will not happen automatically. ठीक है, means कि automatically हमेशा default ही call होगा for the parent. If you want to call some other constructor of the parent, by some other I mean default constructor, not default constructor, but the constructor which is having some argument, then you have to do it yourself. Okay, yourself means you have to explicitly call it. Now how can we do that? Let me just write it and then I will explain. So suppose that we say, okay, whenever someone is calling the parameterized constructor of the child, we want to call this constructor of the parent, not the default constructor. So you have to do it on your own. And how do you do it? You will put a colon here. Okay, and from here you can call any constructor of the base class. For example, we want to call this which is accepting one input, so I can maybe pass it x or any other integer, and then you have the body of this you can say child class constructor. Okay, now let me explain what will happen. When you write this, what happens? You come here. Okay, x is 5, but before executing the body, now you are yourself calling a parameterized constructor of the parent. So what will happen? It will go here. X was 5, so this a will become 5, so you see cout 5, so you see 5 on the screen. Then when this function terminates, you come back to the child class constructor, you execute this body, and you again see a 5 on the screen. Okay, so now maybe I can write both of these on the compiler, show you the output so that you are convinced, and then we'll discuss further. Okay, so I will not be writing anything new, I'll just be writing the same thing, and then we can discuss. Okay, so let's come here. I'll be quickly making the two classes, so maybe I call it class base. Okay, and I will make two constructor in this class, base, and here I will write cout and maybe parent default constructor, and that's it. Okay, so that we know what is going on. Similarly, I will make a constructor int x, Cout. I will write parent parameterized constructor. Okay, and what we can do, we can maybe also print the value which is passed as an input. That's it. Okay, so we have a default constructor, we have a parameterized constructor. That's it. Now we also make a child class, and within the child class again we make two constructors. Cout child default constructor, and that's it. And similarly we make a parameterized constructor in the child class. We enter a Cout. I write child parameterized constructor, and that's it. Okay, so now we have the parent class, we have the child class, a parameterized constructor and a default constructor in each of the two classes. Now in the main, you already know if I make object of base class, it is simple, that constructor will be called, right? So what I will do is I will make object of child class. Okay, so I write here child. Now what should happen? We are trying to call the default constructor of the child class, right? But before executing this constructor, what it will do, it will first call the default constructor of the parent, right? It means we should see this constructor executed, and once it is done, then it will execute the body of the child class constructor. Okay, so let me maybe run this program, show you the output so that you can see that what is actually going on. Let me share with you the output window. Okay, so here is our output window. So you see we have parent default constructor. First the parent class constructor is called, and then we have child default constructor. Okay, later we have the child class constructor which is called. Now let's change it slightly. And what do we do? That for the child class, now I pass an integer. Okay, so it means I am trying to call the parameterized constructor of the child class. But what will happen before executing this constructor? It will again first call the default constructor of the parent, and then it will execute the parameterized constructor of the child class. Okay, so let's see the output so that we are convinced that things are going the way we expected them to be. So let me share with you the output window. So now you see you have parent class default constructor called and child class parameterized constructor called. So in other words, as I told you earlier, no matter what constructor you are calling for the child class, for the parent class, it is always the default constructor which is called, okay, automatically. Now, as we discussed, if you want to call some other constructor of the parent class, okay, now what you have to do, you come here, you put a colon here, okay, and then you can call from here any constructor of the parent class that you like. Okay, so maybe since the default is already called, so I call the parameterized constructor here. So now what is happening here, that let me just explain you. We are calling this constructor of the child class, a is 5, okay, and we put a single colon and we call the parameterized constructor of the base class. So what will happen? And this constructor is called a was 5, 5 gets in x. So you see this executed. When this is executed, you come back here and then you execute the parameterized constructor of the child class. So let me run this program, and in this case we do expect that for both the classes now parameterized constructor should be called. And here you have the output window where you can see that first we have the parameterized constructor of the parent class and then the child class, okay, which actually we wanted. Okay, now there's one important thing. Maybe I can ask you that suppose I comment this, okay, means I do not have a default constructor in the you can say parent class. Now what will happen? Now you see, if you try to make an object of child class, you see it is giving an error here. And what is the error? Error is that we do not have a default constructor in the base class. Now the problem is that whenever I will call this constructor of the child class, first it will try to call this constructor, but there is no default constructor in the class. Okay, so that's why it will not find a default constructor. That is why it is giving me an error. That's why it is a good idea that you, whenever you make a default constructor or a parameterized constructor, you always make both of them. Okay, so that, because there are certain situations in which we don't know that the child class will be calling which constructor. So that's why you should always have the default constructor as well as the parameterized constructor, so that we don't have any issues when we are creating the objects, right? Okay, so let's do a quick recap of whatever we have seen so far. So we discussed everything from the perspective of constructor, right? But the same is applicable to destructor as well. But since normally we do not make destructor in our classes for the time being, so that's why we did not discuss it explicitly. But the only difference is that when you are making an object, constructor is called. And what is the order? Parent and then child. Okay. Similarly, if you have any destructor in your class, so the order of destructors is actually reversed. Reverse means that when the memory is released, okay, your object is destroyed. So first the destructor of child is called and then the parent is called. So you see the order in case of destructor is reversed. In case of constructor, you have parent and then you have child. In case of destructor, you have child and then you have parent. Okay, so this was just a small note. Now we have the same example which we had in the you can say detailed discussion, right? And just for you can say, if you want to convince yourself about the destructor, you can also make a destructor and you can print something, right? So they will be printed in the reverse order. Now as we discussed previously, if you make an object of the you can say child class, okay, first the default constructor of parent is called and then child is called. And here also since we are not calling any other constructor of the base class, so when you call this constructor of the child class, first the default constructor of base is called and then the body of this constructor is executed. Okay, so you can actually make this program and convince yourself. And as you can see that for the destructor the order is reversed. First you have child, this was child class, okay, and then you have the parent class. Okay, but this was just a small note. Practically maybe you will not need it that much, right? So as I told you, if you want to call some other constructor of the parent class, what you need to do, you have to call it yourself. Okay, so if you want to call the parameterized constructor, we are calling it here. So in this case, when we'll make an object of derived class, so first this is executed and then this one will be executed. Okay, so you can actually repeat the same thing and you can convince yourself, right? So maybe now I'll show you a couple of programs and just to check your understanding, maybe I'll ask what is going on here, right? So you have two classes, class A and class B. A has default constructor, a parameterized constructor. B only has a parameterized constructor, okay? No default constructor in class B. And in the main, we are creating an object of class B. So can you quickly tell me the output of this program? You can just type your responses so that I'll just be convinced that you have developed an understanding of this, right? So just think over it and tell me what you think of the output of this program. Okay, let me just see the responses. A default and one. Yeah, okay. So I think almost every one of you responded correctly that first this A default is printed. Okay. So first we see A default and then B is printed. Okay, so the output would be A default and then B, right? And we'll now slightly maybe change it. Okay, now I have slightly changed it. So now what do you think? What should be the output? It should be fairly simple, right? So in this case, you see again, we call this constructor, but here we are first calling the parameterized constructor of A. Okay, so what happens is that first we see this on the screen and then we see this. So you will see A parameter and then B. Okay, so it's good. Okay, so I hope now you have good understanding of constructors. So maybe now we can still be in this discussion, but now we'll be discussing it with a practical example, right? Not AB or parent child, right? With some meaningful classes. Okay, so it will also respond to one of the queries which were posed earlier. So now, rather than taking any classes A, B, C, X, Y, Z, right? Let's go back to our old friend, the point class, right? And this time we'll be doing inheritance. So we have a point class, which is a 2D point, and I'll also make a class which is 3D point. Okay. And again, constructors, but just to convince you that why these are important and how do we do it. Okay. So since I plan to do inheritance, so I am using protected X and Y. And here I will just make two constructors. One is default and the other is parameterized. Okay. So this is the default constructor of the point class. I'm writing X is 0 and Y is 0. Okay. And similarly, I'll make a parameterized constructor, say A and B. So you can write X gets the value A and Y gets the value B, and that's it. Okay, now as we did earlier, we'll be making another class which we call point 3D. Okay, 3D point has three data members X, Y, and Z, but we'll do inheritance, so we don't need to write X and Y again. We can just reuse the point class. So I can make point class parent of point 3D. And within this class, I will just take one data member, which is Z. Okay, and in the public, I will make a constructor point 3D, and I will write X is 0, Y is 0, and Z is 0. Okay, please do keep in mind that point 3D class has three data members. Okay, it does not have one data member. Two data members X and Y, it is inheriting from the parent, and one data member Z is within the same class, right? That's why, and since they are protected, so I can access them from the child class. Okay, they are protected, they are not private. Similarly, when you will make a parameterized constructor of this class, how many arguments you will give? Not one, you will give three arguments. Okay, why three arguments? Because this class has three data members. So I'm calling them ABC so that I don't have to write this. So X gets the value A, Y gets the value B, and Z gets the value C. And here we conclude our class. Okay, let me just correct this so that it is readable. Okay, and now maybe we keep some space for the main program. Okay, now important thing is that suppose someone makes an object of point 3D and they call it P. Okay, so now as you already know what is happening here, we are making an object of point 3D, so we are calling the default constructor. But before this constructor, what will happen? The default constructor of the point class will be called. Okay, now let's see what is happening at the back end. This is your P. You have X, Y, and Z, right? When you create an object, first the default constructor of point is called, means parent is called, and these are executed. What is written here? X is 0, Y is 0. X gets the value, Y gets the value 0. Then you come back here and you call the constructor of the child class, in which again you are writing X gets the value 0, Y gets the value 0. So it means you are again saying change it to 0, change it to 0, and then you are saying put Z equal to 0. So it means that you see these two statements seem unnecessary, although it will not change, nothing will change, but this constructor is already called, you have already given 0 0 to xy, and you are again giving them 0 0, right? So although if you write them, it is okay, there is no problem with that, program will run perfectly fine, but logically these are needless statements, because this you have already done in this constructor. Okay, so that's why when I'm writing this constructor, maybe I can get rid of these. Okay, and I can do something like this. I can just write z gets the value 0, because I already know that x and y will get the value 0 when the default constructor of the parent will be called. So I don't need to repeat it here. Okay. Now let's see the same thing, but now let's see what is going on from the perspective of if I do it for the parameterized constructor. Okay. Now let me do the same thing for parameterized constructor. Maybe I make an object of this child class P, but this time I write 1, 2, 3. Means I am passing 3 arguments. Okay. Now just for discussion, again, see what is going on. This is our P. P has X, Y, and Z. Okay, now let's discuss what will happen here. I am calling parameterized constructor of child, means I am calling this constructor. But before this constructor, what will happen? First, the default constructor of parent class is called. It means I am saying X gets the value 0, Y gets the value 0. Okay, because the default constructor is called. And then I come here and then I say, okay, the values which I had passed 1, 2, and 3, I say, okay, now X gets the value 1, Y gets the value 2, and Z gets the value 3. So you see, it means first you are assigning 0, 0, and immediately you are overwriting them by 1 and 2. Okay, so why actually do this? And we already have something, point constructor, which is assigning values to X and Y. So why not call this parameterized constructor of parent class so that I don't have to repeat these statements here? Okay, so let me just rewrite it and then maybe it will make sense to you. So let me first get rid of unnecessary markers so that they are not confusing for you. And then I rewrite. Okay, so as we discussed, we always have this you can say possibility that we can call parent class constructor uh, from the child class. So what I do is I call parent class constructor and I pass a and b there, because I know they will be copied in X and Y. And once I have done that, then it means I don't need to repeat the same thing here. Okay, so in this function, I just leave Z gets the value C. Now let me explain stepwise how it will happen and how it will work. Okay, so we start again from here. I create an object of child class. We are calling this object P. P has 3 data members, which are like X, Y, and Z. Okay, now you see, we call this constructor, we come here. A is 1, B is 2, C is 3. Before we execute this body, we call the parameterized constructor of the parent class. So where do we go? We come here. Whatever A and B we got, we pass them on. So it means this is 1, this is 2. Now here, X gets the value 1, Y gets the value 2. So it is already done. Now when I come back to this is finished, I come back here. When I come back here, I only have one statement, Z gets the value C, which is 3. So now you see, we have basically written a program which makes more sense logically, that whenever we are making the object with default constructor, I am only assigning value to Z, because I know that in the parent class constructor, X and Y are already assigned with 0 value. Similarly, when I am making an object with the parameterized constructor, rather than first letting the program call this default constructor which gives X 0, Y 0, and then overriding those values, I say, okay, why not call the parameterized constructor of the parent class? Because it is doing the same thing which I wanted. What I wanted, A should go to X and B should go to Y. And this is already happening here. So I put a colon here, I call the parameterized constructor of the parent class, and then within this, I only write this. Okay, so you see, this is basically, this is how we'll be doing things. And one important remark before we take a discussion pause is that, okay, as I keep telling you that normally main would be written by someone else, okay, and classes, maybe it is possible that they are written by someone else, okay. So we are in a academic setup, you are in a lab session or assignment, so you are writing the main and you are writing the classes, okay, but practically this could be different. So you see, when someone else is writing the main, he or she will not know whether point 3D is implemented with inheritance or not, right? It is also because you will not be sharing the source code, so it is very much possible you just tell him that okay, there's a class point 3D, you can make its object, you can call its function. So what this person knows who is writing the main, he only knows that a point 3D has three arguments, x, y, and z, so I need to, whenever I make a constructor, I will need to pass three inputs. Now, whether it is implemented with inheritance or without inheritance, okay, because you can have a class point 3D in which you have XYZ without inheritance. So this is transparent to the main. Okay, that's why main will always pass three arguments, because 3D point है तो 3 point pass होंगे. Backend पे, if they are implemented with inheritance, then the person who is writing the classes, he or she would be managing this, right? So maybe we can take a short pause and have some discussion. Okay, so you see, this is the same example which we were doing, point class, parameter, default constructor, and then you have this default as well as a parameterized constructor. This is the child class 3D. Okay, so what we were discussing it that in the 3D class, when we are doing x0, y0, so when we'll make an object of this class, so this constructor has to be called in any case, right? So you are doing the same thing here, same thing here. So these two statements are pretty needless. You can get rid of them. Similarly, when you are making a parameterized constructor of point 3D, you are copying value in x and y, but you are already doing it in this. Okay, so you can put a colon here and you can call the constructor of the parent class. So as I told you earlier, nothing will change. Your program will behave the way it is behaving, but this is, you can say, the more elegant way of doing it, right? So this is the preferred way of doing it, that in this point 3D, we only assign value to z because we know x and y have been assigned values here. Similarly, when we get three inputs, we pass two inputs to the parent and we assign values to x and y, and for z we are using a single statement here, right? So this is the preferred way of doing it. Okay, so now what we do is, next maybe we can do a complete comprehensive example, which will again you can say, which is again more realistic to your real world problem, where we say okay, there's a university who is launching admissions, right? And there are candidates, okay. So there are two types of candidates who are applying for admission. Some of the candidates are coming from the annual system, in which you have a percentage, okay, that for example total marks were 1000 and you got 900 marks and so on. And then you also have candidates who are coming from a semester system, okay. And of course, for simplicity, we say that whenever a candidate is applying for admission, we'll give that candidate an ID and we'll store the name, okay. But you see, since we have two types of student, okay, so you will have student system students who are coming from semester system, they will have CGPA, okay. And the students who are coming from annual system, we have total marks and marks obtained. Now you see, when you have a description like this, similar to what you had maybe in your exam, so now you have to think yourself that how I will design this solution. Whenever you see a description like this, the key statement is this: two types. Whenever you see such thing, two types, two different categories, it means you are talking about inheritance, right? Because every candidate will have name and ID. So you can make a parent class which has the common attribute name and ID. And then you think, okay, there are two types. So what are the distinction between them? Okay, so let me spend some more time on this because this is very important. You see, no one will tell you that you have to do inheritance. Okay, you have to think yourself. So when I say there are two types of candidates, so you see, okay, there is an annual system candidate and there is a semester system candidate. Okay, then you see, okay, what data I have for him? I have for him ID, name, total marks, and marks obtained. What do I have for this? ID, name, and maybe CGPA. Okay, so you will do some thought process like this, and then you will say, okay, maybe both the types have ID and name. Okay, this is the common part. So you say, okay, maybe I can implement it like this, that I can put the common part here. Okay, and then I can have two child classes. One is for the annual system A, other is for semester system, and I will have ID and name in the parent class because it was common, both actually needed. And then in the annual, I will have two additional data members, total marks and marks obtained. And here I can have a CGPA. So you see, initially all the examples of inheritance we did, there was one parent, one child. But you see, this is not how things will work. Practically, you will have a parent class and you will have more than one child classes. Only then it is useful. And for a practical problem, no one will tell you that do inheritance. Okay, client or your customer will only give you that this is my requirement. You have to think like this and you have to identify, okay, there are some common functionalities between these two types, so I can make a parent class so that I can reuse it. Okay, this will be your decision. No one will tell you. But as I told you, a good hint would be that whenever you see a description in which you see something like there are two categories, three types, so it is actually giving you a hint that this problem maybe can be implemented with inheritance, right? So do look for statements like this which will be telling you that you can do inheritance on this. Okay, now I just made a very rough sort of maybe UML diagram. Now let's do it a bit formally. Okay, if I do it formally, so I say, okay, I will have a class applicant which have name and ID. Why I put them here? Because they are common. Okay, they are required by this as well as by this class, so I put them here. Then for each attribute, I have a get function, I have a set function. Okay, and then I have a print function. What it will print? It will print name and ID. Okay, and this hash symbol, this is for protected. Okay, negative is for private, and plus is for public. Okay, so for protected, you can use this hash symbol. Okay, now these are the two child classes: annual applicant, total marks, marks obtained, get and set function, and a print data function, which will print the all the data of this. Okay. Similarly, one data member, set and get function, and a print function. So pretty simple class, but illustrating a powerful feature. Now let's maybe see the you can say functionality, or you can say the code of this. Okay. So we have a class applicant, we have a string name and ID. Okay. Default constructor, we give an empty string and ID 0. Parameterized constructor, whatever we get, we copy it in the data member. So very much standard process that we have been doing since the beginning of this semester. Okay, now again, very standard get and set function, get name, get ID, return name, return ID. For set name and set ID, you have two function. And this is the print applicant data function in which you are printing the name and the ID. So that's it. Very simple class, just assignment of return and see out statement, nothing else. Okay, no tricky logic, nothing else. Now we make the child class annual system applicant, and the parent class is the applicant. So now we have two data members here, but actually it has four data members. Okay, two data members which are name and ID. It is inheriting from the parent. This is the default constructor. Now the parameterized constructor is important. Okay, how many data members this class has? Four. So I am passing it four arguments: name, ID, which it got from the parent. Okay, and you have marks and total marks and marks obtained, which you have written in this class. So you see, when the person who is sitting on the admission desk, he is filling a form, he does not know that at the back end there is inheritance, because he is not a computer science expert. But he knows that whenever a student is coming from annual system, he needs to provide four fields. He will ask the candidate, what is your name? Okay, he will give him a random or a unique ID. He will ask him, what are your total marks and how many marks you obtain, and he will fill a form. He does not know that at the back end there is inheritance or something. And when he will click on a button, this constructor is called. So all the four values which he has typed, they are stored in the data member. Now what we do, just like we did with the point class, that we call the parameterized constructor of the parent class. So what is it doing? It is actually copying the value in name and id. ठीक है, so यहाँ से उसके name और id set हो जाएंगे, and then just like we did in the point class where we had written z equal to c. So in this case we have total marks and marks obtained, so whatever we get in the constructor we are copying. Now when we make the print function for this, okay, now what do we expect? We expect that it should print all the data of that student, that candidate. Okay, so I can write cout name, cout id, cout total marks, cout marks obtained. Okay, it is easy. I can also write cout name here, and I can write cout id, but I'm already doing it in a function in the parent class. Okay, you see we already have a function which is doing this. So you do there, it is perfectly legal. But why we repeat it when we already have it available? And when you do inheritance, this function is also a part of the child class. So what we are doing, in order to print the name and id, I am calling this function. Okay, because this function में ये लिखा हुआ है ना cout name id, so I don't need to do it again. And I am printing marks and obtain marks within this function. So you see, again, we are reusing this functionality that I don't need to repeat it, because name and id are already printed in this function, and now this function has become a part of the child class. Now let's see the second child class. So in this class we have a CGPA. Okay, so in the default constructor we assign it to 0. Similarly, when you have a semester system applicant, the person sitting on the admission desk will ask the name, give him an ID, and he will ask what is your CGPA. Okay, so it means now he will ask 3 things, not 4 things. Okay, because the candidate is coming from semester system. So again, for name and ID, we call the parent class constructor, and for the GPA we assign here. And similarly, when we have to print all the data of this, for name and ID, we call, you can say, the function which we inherited from the parent class. And then for the CGPA, we are printing it. Now, let's see the main for this. We'll create an object of each child class, and then we'll call the function. Okay. So you see, we have an annual system applicant A, name, ID, total marks, and marks obtained. Okay, so it will actually first call the parent class constructor, set name and ID, and then child class constructor and set these values. Okay. Similarly, we have another applicant who is coming from semester system. We pass name, ID, and a CGPA. Okay, so accordingly constructors are called. And now you can call the print function of each object. So this will print the complete data of this object A, and this will print the complete data of this object S, right? So this is, you can say, a more realistic example. So maybe we can take a pause, and we can now discuss it before proceeding further. Okay, so now basically we see something which is not totally a new concept, but we discussed it earlier, but now we'll see it formally. That you see, there is no limit that you can have a parent class, then a child class, then another child class, another child class. So it is perfectly legal. Okay, so you can have like just like a grandfather, father, child, and so on. So you can do it repeatedly. Okay, for example, there's a vehicle. From vehicle you can inherit car, and from a car, racing car is a special type of car, right? So what will happen is that whatever you have here attributes, they are inherited by this class. Okay, and whatever you have here, it is inherited by this. So it means if there was an x here, so first x comes here and then x also comes here, so it means they are inherited to all the levels. ठीक है ना, यानी कि ग्रैंड पेरेंट के पास कोई चीज थी, it comes to maybe your parent and then child. So it will have everything which you are inheriting in the hierarchy. And please remember, ये जो arrow आपको नजर आ रहा है, this is not UML diagram. This is just telling that data and functions are going there. Okay, if we make a proper UML diagram, then arrow is always pointing from child to parent. Okay, so it would be like this. But here, since it is not a UML diagram, it is a general diagram which is telling you that things are inherited from parent to child. So that's why arrow is pointing from the child, right? So please be careful when you are making the UML diagram. So you see, syntax wise, it's fairly simple. You have a parent class A. Okay, so you have A. B is child of A, so it is like this. And you have another class C, so parent of C is B. So you can again have another class D. So you can keep on doing it as many times as you like, right? So nothing changes from the perspective of syntax. Just to convince you that actually everything gets inherited to all the levels, you have a parent class in which we just have one function. Okay, maybe you are printing something. Then you have a child class, empty body, nothing. Okay, so you had a parent class, then you had a child class, so it means this function is now inherited. And then you have a grandchild class, grandchild. Okay, so this function is inherited here, and then from here this function is inherited here. So it means the function which we made in the parent class is also a member of grandchild, and in the main you can make an object of this. Okay, and you can perfectly call this function. This was just to give you an idea that uh, you will have inheritance to all the levels. Okay, if something is in the grandparent, it is inherited to all the subsequent levels, right? Just to convince you. Of course, this example does not correspond to anything in the real world. If you want to see some example in the real world, then of course you can have maybe a class person. Every person has a name and address. Person, from person we can have maybe an employee. Every employee will have an ID, salary, and so on. And then there can be different types of employees like admin, or maybe engineer, or maybe faculty, and so on. So you see, a person will have name. So name will be inherited from person, it will come to employee, and from employee, so engineer will also have a name. Okay, so this is why we call it like this. Just another recall that if you remember in the beginning, we said inheritance is a relationship. Now you see it makes sense. Every admin employee is an employee. Every employee is a person as well. Yes, it is true. Whoever is an employee is actually a person. So that is why in if you read some books or some literature, you will see a statement that every object of child class is also an object of parent class, right? I'll repeat it. Every object of child class, sorry, is also an object of parent class, which means every employee is also a person, which is true. Every admin employee is also an employee, which is true. And you can also say that every admin staff is also a person. ठीक है ना, वो person भी तो है और employee भी है. So that's why you frequently see this example which or statement which is called that every object of child class is also an object of parent class, right? So this was just a quick recap from the previous discussion. Now let's see the last topic for today. Again, it's fairly simple, nothing very complex, which is called multiple inheritance. What we saw here, it is called multi-level inheritance. Okay, level, why? Because you have different levels, A, B, C. So don't confuse multi-level and what I'm telling you now, which is multiple. Now, what is multiple inheritance? Multiple inheritance means that you have a class, say faculty member. You have a class admin staff. Okay. Now you can also have someone who is a faculty member, but who is also doing administrative duty. For example, there is a dean. Okay. So dean is teaching, so he or she is a faculty member, but he is also an administrative staff because he is also doing administrative stuff. So it means that in the dean or HOD, we want all the attributes of a faculty member and all the attributes of admin. So you see, you have a child class, but you have more than one parent class. Okay, because we want everything from this faculty member to be a part of dean. We want everything from admin to be a part of dean. So this is called multiple inheritance, where a child class will have more than one parent classes. And what is the syntax? It's very easy. You have a class A, like you can think this is FM. You have a class B, you can think this is admin. And then you have a class C, which is like dean. So after colon, you write the names of all the parent classes separated by commas. Okay, so you write public A, means you are talking about this link. You write public B, you are talking about this link. Okay, so you have this class C, there is a class A and B. When you are writing public A, it means you are saying A is parent of C. You put a comma, you write public B, So you are saying B is also a parent of C. Of course, this has certain problems as well, which maybe you can think, but we'll come to those later, right? But let me tell you that multiple inheritance, due to some issues, which I'll come later, multiple inheritance is not supported by all the languages, right? For example, most of the discussion we did for C++, it is also true for Java. But this is a case which we are discussing now, which is not true. You can do multiple inheritance in C++, but Java does not allow multiple inheritance. Okay, means you can only have one parent, one child. You cannot have something like this in Java. But anyways, since we are studying C++, but again, this is a very typical interview question, that how you will do multiple inheritance in Java. So that's why I'm telling you that if someone asks you in an interview, your answer should be, we cannot do multiple inheritance in Java. Okay, now let's see an example of this, and let's see how things will work. Okay, so I had given you this example. Maybe for discussion we see another example, right? Of course, again, this you cannot implement in C++, so this is more for intuitive explanation rather than implementing. Okay, so you see, you have a device which is called printer, which prints data. You have a copier which can photocopy. You have a scanner which scan data. Okay, but you must have seen that today you can buy a device which has all three functionalities all in one, in which you can print, you can photocopy, you can scan. Okay, so just for discussion purposes, we say, okay, if we implement it in C++, although you must know that of course a scanner does not work in C++, but still for discussion purposes we say, okay, so we want to make a device which has the functionality of a printer, a photocopier, and a scanner. So in this situation, what we do, that we have this child class which is inheriting the functionality of a printer. So it means it can print data. It is also inheriting from photocopier, so it will be able to photocopy data, and it is also inheriting the functionality of scanner. So it means now it will have three functions. Okay, what are those three functions? Print, copy, and scan, because there are three parent classes and it is inheriting one function from every parent class. So let's say, okay, since we cannot print data, so for the print function or scan, I will just write a cout statement. Okay, okay, so let's see this. It will actually a hypothetical example, but it will clear your concepts. We have a class printer, and what data we expect? Maybe resolution of the printer. Okay, you must have heard of 300 dpi, 600 dpi, which is resolution, printer resolution. Okay, so this is constructor of the printer. We pass it p, and it is the resolution of the printer. This is the print data function. Since we cannot write the code to print data, so we are just writing cout statement printing data. Okay, just for discussion purposes. Then we have the class scanner. Again, scanner also has a resolution, that how good scanning do you want. Okay, so we have a data member scan resolution. This is the constructor, and this is a function in which we are saying scanning data, simply a cout statement. Then we have a photocopier class. Okay, for photocopier, normally when you buy a photocopier, you ask that what is the speed. Okay, how many pages it can photocopy in 1 minute. Of course, there can be other parameters, but I have chosen this. So I say, okay, what is the speed of photocopy? Okay, so it also has a constructor. Whatever speed we pass, it is copied here, and then it has a functionality photocopy data, and I am simply writing a cout statement. Now is the important thing. Okay, so I request your attention. We have a class all in one. Okay, in which we want all three functionalities. So we will make it a child of all the three classes. So I put a colon. I say printer is a parent of this, scanner is a parent of this, and copier is a parent of this. So when I do this, all the functionality of printer is inherited, scanner is inherited, and copier is inherited. It means now my child class has three functionalities: print, scan, and photocopy. An important aspect is the constructor of this class. Now, how many data members this class has? Three, because it is inheriting one from printer, one from scanner, and one from photocopier. So you see, I am passing it three arguments: printer resolution, scanner resolution, and photocopy speed. I can use assignment operator and I can write statements here. That is okay. But if you want to go for the other syntax where you call the constructor of the parent class, so now you see I put a column. Okay, I call the parameterized constructor of the first parent, which is printer. then the second parent, and the third parent. Okay, you see, it is exactly the same thing which we were doing in the point class, that we were passing x and y, and we were copying z in the same class. But here, since we have more than one parent, so we are calling the constructor of every class. And if you don't call any constructor, okay, still the default constructor of all the parent classes will be called. Okay, we did not make a default constructor, but you can convince yourself that if you do not call any constructor, when you make a constructor of the child class, um, first the default constructor of printer is called, then scanner is called, then copier is called. Okay, so first all three constructor of the parent are called, and then the constructor of this class is called. So that discussion that we did for the constructor is valid in this case as well. Okay, so now you see, you can perfectly make an object of this class. This is for the printer, this is for the scanner, and this is the photocopier speed. And now with this object, you can call all the functions, right? What do I mean by all the function? You can call the function copy data, print data, and scan data. You see, all will work because all of these functions have been inherited by this class. Now, after having said that, there are also certain issues with multiple inheritance. That's why there's a debate that whether we should do it or we should not do it. So let me just quickly tell you that problem, and then maybe we can discuss and conclude today's lecture. Okay, you see, since you have multiple parent classes, so it is possible that there is a parent class A and there is a parent class B. There is a function f here, and there is also a function f here. And once you have a child class, okay, so it is inheriting the function from both the parent classes. Okay, that's fine. Now, if you are calling these functions from within this class, you can always use scope resolution operator. Okay, so there will be no confusion, just like the discussion we had previously. But think what will happen in the main. That in the main, you cannot use scope resolution operator. What you do in the main, you will create an object like this. Okay, C is the child class, and you will call functions like this. So now there will be a problem because in the main you call you call functions with object and dot. Now C is inheriting the function f from A as well as from B. When you write in the main C dot f, so you see your program does not know whether you want to call the function f which is inherited from A or from B. This will be ambiguous. Your program will not compile, and there is no solution to this. Okay, because it is possible that class A was written by someone else, class B was written by someone else. Both made a function print, and you cannot change that because they are written by someone else. So when you make an object of child class in the main, you try to call the function, there will be an ambiguity. And let me just quickly give you an example of this. Maybe you can relate that. Suppose we have a class USB device in which we have an ID, and we just have a constructor and a get function, nothing else. Okay, so we are just trying to model a USB device. We have another class which is called network device, anything which is used for networking. So this class also has maybe a data member which is ID. It has a constructor, it has a get ID function. Now you see we have a get ID function in this class, and we have a get ID function in this class. Now we make a third class which is called wireless card. And wireless card we plug in USB. So we say, okay, wireless card is a USB device, and it is also a networking device because we use it for connecting to the internet. Okay, so now what will happen, that if in the main you will make an object of this class. Now this class wireless adapter, it is getting the get ID function from both the parents. It is inheriting from USB as well as from the network device. So in the main, when you will try to call this function, your program will be confused that which function to call. Okay, because there are two get ID functions, and you cannot use scope resolution operator here because in the main you call the function with object name dot function name. Scope resolution operator you can use within the body of the class. Okay, so that's why multiple inheritance is something which can lead to this problem, and there is no solution to it. Okay, you will have to live with it. It means if you are doing multiple inheritance, you have to be careful that you do not repeat the same name function if you are planning to do multiple inheritance, right? So with that, we'll conclude. I'll just give you a quick summary and then maybe a couple of quick questions. That basically inheritance is something which is very useful. You have already seen that it can help you reuse the code tremendously, right? So you can have different types of inheritance depending upon what problem you are solving, right? So if you have one parent, one child, it is a single inheritance, right? Similarly, you can have multiple inheritance where you have a class which needs the functionality of, maybe in this example, teacher as well as administrator, right? So we need data to be inherited from here as well as here. So this is an example of multiple inheritance. And you can have multiple levels as well, okay, like employee, faculty, administrator. So this is called multi-level inheritance. Okay, you can do it as many times as you like, right? So this was, you can say, a quick summary of inheritance. Maybe I'll stop here for today, but if you have some queries, we can discuss those quickly.